All right, this is the third installment of benchmark number 25. This is, once again, we're talking about quadrilaterals, we're talking about parallelograms. There's about maybe six different properties for parallelograms. And now we want to go ahead and specifically talk about the coordinate geometry, which can be kind of a little bit challenging. So let's go ahead. This is the last example in this lesson. So what are the coordinates of the intersection of the diagonals? And hopefully we understand what all that represents. This is something that gets highlighted right from the start for me. Okay, one more time. What are the coordinates of the intersection of the diagonals of the parallelogram MNPR? Here's the vertices M. Um, the the ordered pair is -3, 0, N, -1, 3, P, 5, 4, and R, 3, 1. So first thing I want to do, I want to start labeling these coordinates. All right, so let's go ahead, -3. Here goes my X, there's my 3. I'm not going any higher. So right there, that will be my M. I'm going to go N, -1, up 3, 1, 2, 3. There goes my N. And I will, well, at this point, well, you know what, let me, I'll talk about that in a second. Let's go ahead and just put down all these points. P, 5, up 4, 1, 2, 3, 4. Again, we know it's a parallelogram because it states it right there. So we know some fundamental properties there. There goes my P, and then R is 3, up 1. So there goes my 3, 1. This is letter R. Okay, the first thing I want to do is I want to start connecting this M to the N. I want to go N to the P. I want to go P to the R. I want to go all the way back here. So there goes my parallelogram. They're saying that the diagonals are, what's the intersection of those diagonals? So let me go ahead with a different color. We'll say, let's go blue. All right, so we'll go, here's a diagonal, and then here goes a diagonal. So what is the intersection of that diagonal? So I'm roughly stating it's probably going to be right here, maybe 1, comma 2. So this is my estimation. So let's go ahead, let's try to figure out what that intersection is. I could do a couple different things here that makes sense. I can start with my N, and I can start with my R. My N coordinate says -1, 3, and my R coordinate says 3, 1. All right, so for me to figure out what the intersection is, I have to do my midpoint. So my midpoint, going way back now, it's going to look something like this. It's going to be x1 plus x2. I'm going to divide that by 2. And I'm going to do the same thing for my y's. My y1 plus my y2. Divide that by 2. And this will be my intersection for N to R right over here. Okay, okay, we'll start labeling this. This is my X1. This is my Y1. This is my X2, and this is my Y2. So let's add this up. -1 plus 3. Divide that by 2. 2 divided by 2. Just looking at my x's, it's going to be 1. Right. And then for my y values, I have 3 plus 1. So I'll add those up. 3 plus 1, divide that by 2. 3 plus 1 is 4. 4 divided by 2. And then here goes my midpoint. I'll see if this looks good to my guess. Looks good. It's not a guess anymore. We just verify that by using the midpoint formula. 1, 2 is the intersection for these diagonals. Hey, let me know if you have any questions on this. You'll have a benchmark on this. I think on the benchmark you'll have some questions that talk about midpoint. You have some questions that talk about distance. But let me know if there's any questions. All right, this is your chance to try to work this problem out. It's the guided practice. This is the last example that I'll be showing you guys. I think the first thing that you would like to do here is just make sure you label each of these points. You're plotting it on the coordinate plane, and then you're trying to figure out what is the intersection of those diagonals. The same thing we did last time. If you need some graph paper, let me know. Good luck. Talk to you later. Bye.